Based on the industry's most advanced deduplication technology, HP StoreOnce and HP Data Protector together are the only solution that offer the flexibility of federated dedupe. That's at the application source, the backup server, and in the hardware target appliance. This helps organizations to meet their most demanding business SLAs while they minimize overall infrastructure cost. HP StoreOnce provides the only option in market today that allows organizations to deduplicate a single time across multiple locations through enabling zero hydration replication support. This allows organizations to maximize their critical storage resources through the most efficient deduplication available, while meeting those critical business SLAs and minimizing backup-related costs. Let's begin our demonstration by creating a backup specification and enabling application source dedupe. Throughout this process, you will see how simple and easy it is and how powerful the results can be. As we create this policy, it's important to note that we're enabling dedupe at the source, where the data is being created and utilized. This technology used within this method is the exact same technology throughout each approach and is inherent to both HP's backup-related software and hardware. Let's now browse the file system on this particular disk agent and select an area to protect. Note that it's totally feasible for many application servers in a remote site or regional data center to have very similar data. This approach to deduplication enhances the storage efficiency and is essentially application agnostic, meaning that there are no differences in how we dedupe at the file system level or database or even in a messaging platform. StoreOnce dedupes equally across all platforms as it leverages a considerable smaller chunk size, on average 4K in size. This is accomplished through our unique technology within HP StoreOnce known as adaptive microchunking. Let's select our data and proceed to the next step. After selecting the source data, we will then select the device in which we will back up our application data to. It could be either a DP media server using software dedupe, or it could be a hardware dedupe such as the HP's B6200. As you can see here, there is an available target on the B6200. Let's use this device. As well, we'll select the default protection period for all backed up data. And we'll set the length and time as well. We'll choose 5 days. In addition, note that the source-side deduplication option is set for this backup to disk device option, as the policy is aware of the target can be supported by this function. Next, let's accept the default schedule, and then let's save this new backup spec as backup test number 3. Finally, let's start this backup immediately by selecting Start Interactive Backup. You'll now see in the status window that the backup is started. The system attaches to the target device to start the process. In addition, we could have configured this policy to utilize multiple devices. By doing so, the device drives greater parallelism, providing greater performance and scale during the backup process. As a side, our backup is not only highly efficient, but also application consistent through our integration with Microsoft VSS and native storage hardware snapshot technology. In fact, we could leverage our zero downtime backup and instant recovery technology. As the backup process continues, you'll notice the status shows the amount of data processed by which device and its total percentage complete. During the backup process, we are deduplicating at the source by comparing hashes of the data against the system library. Only the unique data is being sent to the target device. A majority of the benefits of application source dedupe are related to how it's extremely network efficient as well as storage efficient. This is particularly relevant to those environments that utilize a wide area network where the connection is of high latency and low bandwidth. As the backup process has completed, the status shows that we have backed up roughly 5 gigs of data and that it is aware of the dedupe policy capability, indicating here as source-side deduplication as its type. We have achieved a massive amount of storage efficiency for this transfer at an amazing 5,287 to 1, taking less than 20 seconds to complete the backup process, transferring only a meg of actual data between the application source and the target device. As well, many data center applications have a high level of redundancy in information, as many servers' content can be very similar, such as system files, common libraries, user-related data, etc. Dedupe is a huge benefit to the backup process and to the bottom line, because you can store much more with less in a fraction of the time. Let's now repeat this process, backing up the same host, but instead we'll leverage server-side deduplication. As we proceed with creating this backup specification, notice that source-side dedupe is not enabled. In this case, the media server or gateway itself will perform the deduplication function and not the application source. we'll choose a similar portion of information within this host file system and initiate the backup to a different target device. For instance, let's select HP Data Protector and we'll back up the HPDP62 directory. As we browse the available devices on the B6200, you can see that there are many available for our use for server-side dedupe. Again, we could select many for better concurrency and performance if we desire, but let's just go with a single device and move to the next screen. We'll again select the default protection as we did earlier, indicating 5 days once again for retention. And once again, we'll leave source-side dedupe unchecked. In this case, any data backed up by the media server will be deduplicated at this level alone, not at the application source or within the target device. Let's accept the default schedule and continue. Let's save this backup spec as backup test 4, and once again we'll run this backup job interactively, starting our backup now. As our backup process initiates, we will see within our status window that our disk agent is communicating with our defined target from within our backup specification. Also note that we're leveraging Microsoft VSS for an application-consistent image of this file system. As we process the data that's being copied, it's being compared to a hash, and all data is being deduplicated from a redundancy perspective at the backup server level. You can see quite clearly from the status that the policy that we're using reflects that we are leveraging server-side deduplication. And again, we've backed up roughly 5 gigs of data with only transferring 3 megs of information, giving us a generous deduplication rate of 1878 to 1. As more servers back up to this media server, redundant data will be deduplicated and we'll only store the unique blocks. Again, our approach to deduplication is application agnostic in nature, providing predictable dedupe ratios across all applications and supported environments. This ends our demo of the HP Data Protector and HP StoreOnce integration, proving maximum storage efficiency through federated dedupe at the application source, server side, and within the hardware appliance. This new feature brings the power and simplicity of deduplication delivered through HP StoreOnce, thus maximizing the storage efficiency for backup and recovery in 3 locations. This means a drastic reduction in cost and complexity for managing a highly distributed and diverse data center. I want to thank you again for taking the time to view this demo of HP Data Protector's federated dedupe through HP StoreOnce. For more information about this feature and HP Data Protector 7, please go to imhub.autonomy.com.